So let's start here. So again, we'll join the quizzes class at the end. We're going to go over that worksheet, the problems together. Then I'm going to give you a lecture. In other words, we're going to talk about lesson 3.3, which you should have already watched that 12-minute video last night. So that should be a little familiar. Then we're going to do a couple of problems on page 80 together, which is basically inspection. And then you'll have a big ideas math assignment, which I think it's due like tomorrow night, like at 8 o'clock or something. So you have between today and tomorrow. And by the way, if any of you are affected by something crazy like COVID or a fire, for instance, and your life gets taken over due to no fault of your own, feel free to email me or text me or chat or whatever. If you need more time, it's never a problem, okay? Unless we're going to take a test, but we're not anywhere near a test. So I just want you all to know that. Not a problem at all. Take care of yourselves and be safe. Now, if you would all please make sure you have your student journal. I'm going to change to the camera so we can all look at our homework together. Oh, wait, one more thing quick before I do that. And some of you turned in the extra credit, yay, which is really cool. I just want to check before we start today. Here's the practice worksheets. Okay, turned in. Okay, Lincoln, can you make sure, and Brandon, Riota, can you please make sure to attach, and Natalia, turned in, and no, Priya already talked to me. Just make sure you attach that work before class starts. And then after we go over it, feel free to do that. But this just tells me you have it done now. It says viewed, but if you didn't, take a second and attach that right now, please. Okay, now and don't worry about that. That's not anything. Camera. Okay, so you're gonna get this out, please. We started, remember the backside together, which was A, and we're gonna go through each one. Yours should have more work than this. These are just the answers. Or yours should have reasoning also. So I will go ahead and zoom in on here. So give yourself like a star, a C, a happy face, whatever works for you that tells you you're good. And then I'll go ahead and I'm going to verbalize what your answers should also have before we move on. So we're reviewing 3.2 first. So here, when we talk about which theorem you're going to use, first of all, both measure 1 and 2 are 41. The reason for number 1 is because of corresponding angles. They're in the same spot, corresponding angles. So you would have to put the words like core angles congruent right next to the 1, and that's equal to 41. And then the angle 2, you could actually write 2 different reasons. You could say 2 is congruent to 40. This one, you could say by vertical angles, if you want to, or you could also use alternate interior angles, because 1 and 2 are on the inside of these 2 parallel lines and on opposite sides of the transversal. So you could have either one of those reasons for number 2, either alternate interior angles or vertical angles. So you can see why I couldn't put it all on here. Number 2, if you look at the measure of angle 1 first, here's our parallel lines, and this is our transversal. So 124 and 1 are both 124 degrees because of alternate, meaning opposite sides of the transversal, exterior, which means outside of these two parallel lines, exterior angles are congruent. Okay. Another reason for number 2 is you could say that these two are vertical, or because this was a new one, you could say angle 2 and this one are corresponding. So you could write corresponding with angle 2, as long as you got 124. Again, if you have a question, pop your hand up, because I can't, while I'm doing the camera, I can't see your faces. But I'd be happy to answer anything. Otherwise, give yourself stars and happy faces if you got these correct. So on number 3, and all this says is find x. But I'm going to notice here that here's my parallel lines, and here's my transversal. So this angle here and this angle here are, again, alternate exterior angles, which means they're equal to each other. So on your paper, I should see this work. 3x minus 8 equals x plus 24. It says show your steps. Of course, I'm going to take away 1x from both sides, or here, and I get 2x on this side. I'm going to add 8 to both sides here to get 32. And then I'm going to divide both sides by 2 since x is multiplied, and that's where I get the x equals 16. So that's enough work, definitely. So it said find x and show. So I did both of those. Okay. Number 4. Now this is our consecutive interior angles theorem. So here's our parallel lines. Here's your transversal. These are both on the inside of these parallel lines, and together they make 180. So your work would be 2/3 x plus 27 equals 3x minus 25. And of course, you would show your work all the way down until you got x equals 51. Now, if you started with this and you didn't get to 51, that's an algebra mistake, which I could certainly help you with, but I'm going to just continue the geometry first. Okay, no hands. I'm looking for hands. Okay, now, again, we're going to talk about relationships. 1, 2, and 3, explain your reasoning. So even though I only have these answers, you should also be writing the reasons. So let's look at 1 and 2. No, let's look at 1 first. Okay, angle 1 is 102 because it's an alternate interior angle. These are parallel, these are alternate on the opposite sides of the transversal, and they're interior. So that should say alt int angles congruent. Now, I'm going to go over to angle 3. No. Where do I want to go next? I want to go to 2. So now I know 1 is 102. Now I'm going to look here and here because those are on the same side of the transversal and in this, both to the left of the parallel lines. So those are corresponding. That you should have corresponding somehow. You could also, if you wanted to, you could ignore this one here. Just completely ignore that angle. And if you're looking at these two parallel lines, then angle 2 and 102 are alternate exterior angles. So you could also list alternate exterior angles. And then finally, number 3 creates a linear pair with number 2. So 2 plus 3 have to add up to 180, which is why you get measure of angle 3 is equal to 78. And, you know, I would say something like linear pair, or you could say definition of supplementary angles. So either one of those will give you angle 3. So you sort of chip away at each one. Now, I look at number 6, same thing. First, I'm going to start with the measure of angle 1. Back to my colors. So here's my parallels. Here's my transversal. That means this angle is the same as this angle. So measure of angle 1 is 68. Okay. Now, I'm going to look for 2, and I see 2 down here. But it has nothing to do with this up here. So basically, you're going to ignore this third one. You're not even going to look at it. And you're going to ignore this line over here. You're not going to look at that. So really, you just have to sort of isolate where the angles are to figure out what's going on. Here's my 2 parallel lines. Here and here. I have angle 1 up here, and it relates to 3 by being an alternate exterior angle, because it's outside of my parallels. So there you go. Now angle 2 is 68. Then to find number 3, now I'm going to ignore this, and I'm going to ignore this. I'm just going to focus in on that part. Hopefully you can see that angle 2 and angle 3 are consecutive interior angles, and consecutive interior angles are supplementary, which means all I have to do to find angle 3 is subtract 68 from 180. And you'll see that's why I put that reason. Consecutive interior angles are supplementary. I'm hoping that you'll see how these colors really help pop things out, especially when the picture gets very convoluted. Just try to focus on the one small thing. So now we'll go back to this one, 7 and 8. This figure shows a 2-dimensional representation of a bird made out of origami paper. And I, again, try to circle it for you. You're going to find measure 1 and measure 2. So first of all, looking at measure 1. This one is in the same place as this one. So by corresponding angles, angle 1 will be the same as this. I also know that angle 1 is across from here. So by vertical angles, that's going to be equal. But now I have this angle here equal to this angle here. They're both that green color. And so I can write an equation to solve for x. So I write 3x plus 5, that's the same as this. So 4x minus 30. I'm going to subtract 3x from both sides. So on this side, I only have 1x. And then I'm going to add 30 to both sides to make this 35. So now that I have x is 35, I can pop it into here, where it's either 4 times 35 and then minus 30, or I could take it over here, 3 times 35 plus 5. Both of them will give you 110. Once you get 110, then you have to find this other one, where angle 1 and 2 are again linear pairs. So they're supplementary. So to find 2, you would do 180 minus 110, and you get 70. So you sort of chip away at each angle on these problems. Make sure you have your reasoning explained on your paper, which is why I suggested you might want to do this on line paper, but that's okay if you didn't. Now, I almost feel like I should like erase this and start over. This one is again where you want to look at each one separately, but because there's 3 sets of parallel lines here, you want to look at each set separately. So if I started with the angle 1, here's my first set of parallel lines, and it's asking which ones are exactly the same as angle 1. Okay, so angle 1 is in this corner. Angle 1 is not along this transversal. So what I can do is say that angle 1 is congruent to angle 6. And that's by, so from here to here is congruent to here. And that's by vertical angles. Okay. Now, I can also look straight up. And this is where I'm going to do a different color. If I'm on this set of parallel lines, now just look at the green, try to ignore the black, then this is a corresponding angle. So 10 is corresponding. Now, if I also look at the green, then, and along here, then angle 5 is alternate interior from these two. So now if I look at the pink lines here, then angle 1 and angle 5 are alternate interior. Now, if I look this way, I also see that angle 7 is alternate interior angles on the opposite side of this pink transversal. And since I have 7, now I can look up this way and look at the pink ones. Angle 7 is congruent to angle 3 by corresponding angles. And then finally, angle 3 is directly across from angle 9, and we're going to call that vertical angles. So you should have 1, 2, 3, 4, 5, 6 different angles that are congruent, and especially since there's 3 different sets, I would always suggest keeping pencils, colored pencils, pens, something that's a different color nearby. So questions right now? Okay, well, feel free to unmute yourself and ask a question at any time. I'm going to go ahead and turn this over because, oh, wait. No, I wanted to look at, so keep this near you. You've got that done from your notes. What I'd like to do next is go to the journal. Okay, so please open up your journal on page 76. That's where we're going to start. We're going to go through these next 5 pages fairly quickly because it's a lot of pictures. But these theorems should look familiar to you because you watched the video yesterday. So in 3.3, we're doing proofs with parallel lines. And what we're going to try to figure out is for which of the theorems involving parallel lines and transversals is the converse true? So we have to remember, of course, what the converse is. It's the converse true. So from section 3.2, we got theorem 3.1, 3.2, 3.3, and 3.4 is on the next page. And this is a statement that says, if you have parallel lines cut by a transversal, then you get corresponding angles are congruent. And this is like a P statement, and this is like a Q statement. This was from chapter 2, when we were doing conditional statements. So if P happens, then Q happens. We did this. We did P implies Q. Well, now the converse, if you recall, is where we switch them. We do that Q implies P. So what we're actually really going to want to write here when it says write the converse, here's what it would be. It'd be if the pairs of corresponding angles are congruent, then the first one would happen. Parallel lines are, then you have parallel lines. I'm just going to say you have parallel lines. Okay, so that actually means both ways. And I can see that that is true. I'm also going to look at alternate interiors. So if I get that 3 is congruent to 5, then I should be able to say that they're parallel. So it's exactly opposite. So the alternate interior angles theorem says, if you have these two parallels and it's cut, then you get 3 congruent to 5. The converse says, if, so here's my P, here's my Q, if alternate interior angles are congruent, then you have parallel lines. That's the converse. We're going to do this for each one of our theorems. Alternate exterior. So now we're looking at 1 and 7. So here's our if, here's our then, here's our P, here's our Q. We're going to say that if alternate exterior angles are congruent, then lines are parallel. Okay, so I'm going to turn the page to 77, where we're going to talk about that last theorem about consecutive angles that are supplementary. It's just a little different, but if you have two parallel lines, then the pairs are supplementary. So our converse is, if consecutive interior angles are supplementary, then lines are parallel. Okay, and that's going to be true for all 4 of those theorems that we got the other day in 3.2. So we're going to move on then and actually see what those theorems look like. Actually, yeah. So on 78, here's the vocabulary we've been talking about. And lo and behold, here's the theorem. If 2 lines are cut by a transversal so the corresponding angles are congruent, then the lines are parallel. So that's exactly what we just wrote on that page before. And now they're giving it a number. This is the converse of 3.1. And now we're giving it a name. It's called 3.5. So if you get this picture right here, where 2 and 6 are marked the same, this would be a given. If you're given this, then you get this. Okay, that's automatic. That's what the theorem says. Next page, we're going to go through each one of these fairly quickly. At Theorem 3.6, if you're given alternate interior angles that are congruent, then you get that the lines are parallel. Do the same thing. So this is the converse of 3.2. Of course, you can call it the alt and angles converse as well. So if you get this, then you know you have parallel lines. Alternate exterior also. So again, if you have alternate exterior angles are congruent, then the lines are parallel. And this is the converse of 3.3. And if you get this picture where they are marked the same, then the theorem says you have parallel lines. And this theorem works the same way. If you have two lines that are cut so that consecutive interior angles are supplementary, then you get parallel, which means you actually have to know that 3 and 5 together are supplementary. But then if you do, you get that J is congruent to K. J is parallel to K. And that is the converse of 3.4. So we started out with the first 4 angles, theorems, then we did 5, 6, 7, 8, and now just one more theorem because they're all going to start to blend together here. So the one last theorem has to do with the transitive property of parallel lines, which sort of makes sense. You started learning about what makes a parallel line in like 7th grade. You should have. Well, these all are going to have the same slope. So no matter where they start, since they go on forever and ever, if you know that 2 lines are parallel to each other and that one is parallel to another one, then it transfers. Okay, so it's transitive. So if you know you have these parallel and you know you have these parallel, then you get P parallel to R. That'll come in handy later on. And there's no converse of that. It's just, it's like the law of syllogism. It's like transitive, transitive property. That's what it is. It's a property. Okay, so any questions right now? I'm trying to make it nice and color-coded. And so we're going to use these theorems now that we have more theorems. We're going to use them to do problems and also proofs. That's what we'll be doing tomorrow. We'll be doing some of these as proofs. So everybody, let's turn your page to page 80, where we're going to do a little bit of extra practice here. These are the kinds of problems we're going to work on. So in exercises 1 and 2, find the value of x that makes m parallel to n. These are both in the same spot on the same side of the transversal. Those are corresponding angles. We know if we have corresponding angles that are congruent, then we get parallel lines. So you would write 95 equals 8x plus 55. And at that point, you're going to subtract 55 from both sides. And then you're going to divide by whatever's multiplying x. So 40 divided by 8 is 5. Just quick check. If I take the 5 here and I put it here, I get 40. 40 plus 55 is 95. So yay, I know I'm right. Okay. Number 2. Oh, I forgot to explain. So really all you'd have to do is say by corresponding angles theorem, and then write corresponding angles theorem. Okay, now this one, my parallels are going this way, and this is my transversal. So hopefully if you, maybe you'll see it like this. These are on opposite sides of the transversal, and they're outside of where my parallel lines are. So these are going to be exterior. They're alternate exterior angles theorem. You can write that they're equal to each other. So 130 equals 200 minus 2x. I'm going to subtract 200 from both sides. And then I'm going to divide both sides by -2 because it's multiplying my x. And I get 35. So just in case, if I want to put this into here, 2 times 35 is 70. 200 minus 70 is 130. So I also know, again, I am right. So I put a box or a circle around my answer because it makes me happy. Okay. Last, these are just sort of inspection. So let's read the directions. Decide whether there is enough information to prove that M is parallel to N. If there is, state which theorem it is. So all I know is that this is the same as this. Is that enough to say that M and N are parallel? And if it is, which theorem? Do I have any volunteers? Which theorem does this look like? You have pictures. Okay, so I'm not digging the nobody answering me thing. So it looks like this, where they're in the same place. So you'd say, yes, by the corresponding angles converse theorem. There is enough. Okay, number 4. I have this angle here. It's marked to be congruent to this angle here. Is that enough to have M and N parallel? What kind of relationship do these two angles have? What do we call them?
Vertical angles?
They are vertical. Do we have any theorems that say anything about vertical angles and parallel lines?
Yes.
We do. So sorry. What is it?
Let me see what it's called.
Which one? Yeah, so you look in here and you go, where are my notes? What are my theorems? And thank you for speaking up. You're looking, Andrew?
Yeah.
If you find a theorem with vertical angles and parallel lines, I'd really like to know what it is.
Can't find any.
Well, that's because there are none. We don't have any theorem. So thank you for letting me kid you a little. We don't have a theorem that says anything about vertical. So this is not enough to say that they're parallel. Even though they look like it, if they don't have those little triangles, this is not enough information. And look at this one. See, even though there's like a ton of different relationships, these are also vertical. So no, there's not enough information. However, when you get down to number 6, I've got one here and I've got one here. So clearly this is the transversal and they would be alternate something. What are they?
Alternate exterior angles?
Yes. Now, Max, why can you say that they are exterior? I mean, what about S in the middle?
Am I allowed to look at my notes?
Of course, you're
Okay.
always allowed to look at your notes. And I'm asking anybody, in this picture, does S matter at all?
No.
No, it doesn't. So watch what I'm going to do. Okay, now are they alternate exterior for sure?
Yes.
Yeah. So you can do that. You can, that's one of the reasons if you know they're parallel. So for sure, and you'd say yes by alternate interior angles converse theorem. You know, you could say the angle, the number it is, whatever this number is, alternate interior, you know, you could say theorem 3.6, but I don't memorize. I've got enough stuff to worry about, so I don't memorize the numbers. You could if you wanted to. Okay, so questions right now, questions about what your homework's going to look like and things like that. Then tomorrow we'll do some more proofs. Today you're going to do more problems like this and big ideas. So I'm going to come back to the thing and let's all try to log into quizzes because that's the only other thing I wanted to do. And I'll keep it recording. So I'll show you my screen as much as possible. So you're all going to do this for me. You're going to go to the agenda. And you're going to click on this link right here. This is period 6. Now it's going to ask you to register. So please do so. And then come back and click it again after you're registered, and then it will add you to my class. So if you click this, here's what should happen. Except that I'm already registered, but it says, Jackie Payne invited you to a class, and then it should have your name, and I think it asks your birthday and email. And then use your school ID for the email. So use your school ID for sure, whatever your number is. Now, if you have accept invite, great, click that. But if you don't, once you register, you can go back and click it again. And this time it should just add you to my class. Of course, and if you want to edit the way your name looks, you just click the pencil. You put your email and you accept.
Miss Payne?
Yeah.
So I have a question. So since I'm in 9th grade, this is 10th grade math. When it asks my grade, do I put 9th or 10th?
Yeah, I'd put 9.
Okay.
You're in 9th grade. Yeah. Because you're going to be in my class, which I'm showing you what I see. This is the teacher side. I will see you on period 6. And right now, there's no students, but this is the code that will invite you to my class. That's what the link in the agenda says. And that's all I wanted to do today was just link you to this class. And so only 5 people in period 1 was successful. We got 17 in period 4.
Miss Payne.
Yeah.
What is the code again?
Okay. So I'll go. Oh, 7 of you just did it. Okay, so.
Do you want us to sign up with Google or like our student address?
Student email.
Okay.
Student email, yeah. Where's the code again? Where did I put it? I don't want that. It was right here. Edit class details.
It's on the daily agenda.
Right, but I thought I had it here too. So let me just go back to the daily agenda. So you click, there it is, R536572. You just hover over it, it gives you, then you click it. For students. So I know it's a two-step thing, but I'm hoping that we will be able to use this. I want to do it tomorrow. Do the quizzes. I'll assign you a quizzes and we'll see what happens. If you can get on there. And then once you're, yay, look, Mia, Sierra, Maya, Lucas, Lincoln, and Connor were able to get in right away.
Wait, I'm
And
sorry.
then-
Can I put the code again?
Okay, go to the agenda
Okay.
and click that link and it should, or hover over it. You can, don't do the thing in the corner. That's for a quiz. That's not to be added to a class. So
Asking for like a guardian or something, a parent's email or something. Do we do that?
you put your email in there, put your school email.
Okay.
So there's two, you can join a quiz without having an account. I'm trying to get you to have an account so I can assign you a quiz.
Okay.
So,
Yeah, I got it.
oh, good. I'm gonna refresh so I can see.
Right.
Yeah.
Alright, I don't know if I joined or not.
I don't see you yet, but I haven't refreshed. So here.
Miss Payne, I entered in the code, and then when I press join, it says please match the requested format.
I see Joey. I don't know what that means. Actually, I have 16 of you now. Let me see. Please match the. No, Matt, you're right there. Can you see your name?
Oh, I'm in it? Oh.
Yeah, and see there's Max.
Oh, yeah, never mind. Okay.
So it's not completely clear to me how to do this, but I sent you all that link is an invitation, and then you had to sign up. And then once you sign up, now I've got 17 of you. Okay, so once you're in here, once you've done this, go to Big Ideas and work on that. And like I said, I think it's due tomorrow evening. So juggle your time the way you need to. And then tomorrow we'll do a quizzes in class for 3.3. Okay, we're not doing new stuff tomorrow. We're just going to practice this stuff.
I have a question.
Yes, Hide.
Do I need to make an account for school email or my private email?
It's school email. Do the school email. Yeah. And you can probably even do it without that email, but Sophia added. Okay, so I have 17 students who have added. Anna, Ashley, Brendan, Connor, Isaac, Lincoln, Lucas Emery, Matt, Maxime, Maya, Natalia, Robert, Tiger, Zaya, Mia, Priya, and Sierra have all been successful. Yay. Okay, so you're excused once you get that done. Of course, it's after 2:45 now. Holy cow. All right, I got to stop this meeting. Stop.